Today we are going to learn quadratic functions. Why do we want to study quadratic function? Because many events in this world happen according to the quadratic function. For example, when we throw a ball, or when we fire a cannon, the path traveled by the ball and the cannon follow the quadratic function. In the past, we have learned linear function. If we plot the graph of a linear function, we get a straight line. We can draw any linear graph if we are given the gradient and the y-intercept. So, a linear function can be expressed as y equal mx plus c, where m is the gradient and c the y-intercept. Today we are going to study quadratic function. If we plot the graph of a quadratic function, we get a shape like this, which is a little bit more complicated than a straight line. It can also be inverted. For all quadratic functions, there is always a vertex and also an axis of symmetry. So the left hand side and the right hand side are symmetrical. The general form of a quadratic function is ax squared plus bx plus c. And we are going to study this closely today. This is the general form of a quadratic function. We are going to see the effect of the value of a, b, and c have on the graph of quadratic functions. First, let's look at a. When a is positive, for example, y equal x squared plus 3, the graph that we will get is like this. When a is negative, for example, y equal negative x squared plus 3, the graph that we get is inverted. Next, we look at the effect of the value of a on the graph. This is the graph of y equal x squared. Here, a is 1. What does the graph of y equal 2x squared look like? Let's look at these points. For y equal 2x squared, all the y values of these points are going to be multiplied by 2. The point in the middle is unchanged because the y value of that point is 0, and 0 times 2 is 0. What does the graph of y equal 1 over 2x squared look like? For y equal 1 over 2x squared, all the y values of these points are going to be multiplied by 1 over 2. The point in the middle is unchanged because the y value of that point is 0, and 0 times 1 over 2 is 0. If what we have is y equal negative x squared, here a is negative 1. This is the shape of the graph of the quadratic function now. We go through the same process, and we will find that y equal negative 2x squared is going to look like this. And y equal negative 1 over 2x squared is going to look like this. Next, we look at c. This is the graph of y equal x squared.
If what we have is y equal x squared plus 2, then the y value of every point will be added to. The shape of the graph is unchanged, but the whole graph is moved upward by 2 units. If what we have is y equal x squared minus 3, then the y value of every point will be reduced by 3. The shape of the graph is unchanged, but the whole graph is moved downward by 3 units. The same thing happened for the quadratic function that is inverted. If we have y equal negative x squared plus 4, then this whole graph will be moved upwards by 4 units. If we have y equal negative x squared minus 2, then this whole graph will be moved downward by 2 units. Lastly, we look at b. This is the graph of y equal x squared. Here a is 1, b and c are 0. And this is the graph of y equal x. We want to draw the graph of y equal x squared plus x. Here a is 1 and b is also 1. What we do is to add up these two graphs to get the graph of y equal x squared plus x. 2 plus 4 is 6. 1 plus 1 is 2. 0 plus 0 is 0. Negative 1 plus 1 is 0. Negative 2 plus 4 is 2. We can see that the shape of the graph is unchanged, but the whole graph is moved to the left. How about this one? Y equal x squared minus x. To get the graph of y equal x squared minus x, we add up these two graphs. Negative 2 plus 4 is 2. Negative 1 plus 1 is 0. 0 plus 0 is 0. 1 plus 1 is 2. 2 plus 4 is 6. And we can see that the shape of the graph is unchanged, but the whole graph is moved to the right. So for the case where a is positive, that is when the shape is like this, the positive b will move the whole graph to the left. And the higher the value of b, the further to the left the graph is moved. Negative b will move the whole graph to the right. The higher the value of b, the further to the right the graph is moved. You can check for yourself that for the case of a is negative, that is when the shape is like this, the effect of b is opposite. When b is positive, the graph is moved to the right. And when b is negative, the graph is moved to the left. Diagram show the graph of fx equal x squared minus 6x plus 10. Sketch the graph of gx equal x squared minus 6x plus 6. These parts of the two functions are the same. The only difference is here. From fx to gx, the value of fx is reduced by 10 minus 6, which is 4. So every point on the graph of fx is going to be reduced by 4. Since this is just a sketch, we are going to make use of the minimum point. The y-coordinate is going to be reduced by 4. And we get the new minimum point. And this is the graph of gx equal x squared minus 6x plus 6.